This hot piece of metal is glowing red, orange, and yellow. Why is this metal glowing these colors? The answer is that it is extremely hot, thousands of degrees hot. The glowing is the result of heat producing electromagnetic radiation, also known as light. Hot things cool down. There are three ways that they do that. First is conduction. If you've ever touched a hot stove, you know how this works. When two pieces of matter with different temperatures touch, heat flows from hot to cold. Second is convection. If you put your hand above a hot stove, it still feels hot. This is because in any fluid, hot things dump heat into the medium. When the hotter gas spreads out, it may hit nearby objects and transfer heat. The third method is radiation. Radiation is how the sun manages to heat Earth. The sun isn't touching our planet, nor is there a fluid that runs between us, so it can't be conduction or convection. The way that radiation transfers heat is through light. The energy of nuclear fusion in the sun becomes the heat of the sun, which in turn becomes light that hits Earth, which becomes the heat of the Earth. That is how radiation works. Everything is constantly radiating away their heat as light, even cold objects. Cold objects, however, when surrounded by hot ones, have less energy output in radiation than the energy input from the hot objects. The amount of heat energy an object has is proportional to the amount of radiation energy it emits. Every object emits the same number of photons per second per unit of mass, so the energy difference comes from the wavelength of light. Shorter wavelengths of light have higher energy, so hotter objects emit shorter wavelengths of light. That is why this metal and fires at thousands of degrees emit visible light, while human bodies at hundreds of degrees emit infrared light, which has a larger wavelength. To calculate the wavelength of light that an object emits in meters, you simply divide 0.0029 by the temperature in Kelvin. Human bodies at a temperature of 310 Kelvin emit a wavelength of 9,350 nanometers in the infrared range. The sun at 5800 Kelvin emits a wavelength of 500 nanometers, the color green. But the sun isn't green, so what's going on? The answer is that this equation, known as Wien's law, only describes the peak emission wavelength. The actual wavelengths emitted are on a curve, with the peak at 0.0029 divided by temperature. Although the sun's peak wavelength is green, there is enough blue and red that they combine and look white. Fires look red, orange, and yellow because the peak wavelength is in the infrared or very red part of the spectrum of light. This means that the visible light is heavily slanted towards red, orange, and yellow, so the fire looks those colors. Very hot fires, as well as very hot stars, can look blue because of the peak wavelength being in the deep blue or ultraviolet part of the spectrum of light. This slants the light towards blue, which makes it look blue. Overall, temperature versus perceived color looks like this. There are no green stars because of the way that the emission curve, known as the blackbody curve, behaves. Radiation is just light, and different temperatures produce different wavelengths of light.